Okay, and welcome back. In this video, we are going to solve the problem about a projectile motion that we have discussed in the previous video. Okay, so the question is like this. On a distant planet, that means we don't know the g value, a projectile of mass 2 kg is launched horizontally with initial velocity 45 meters per second from a certain height. So the most important thing to do is to draw the diagram as soon as you read the question. So now what do we see first? We see that it is drawn horizontally and from a certain height. That means it is not thrown from a level ground. So first let's make a height and start with a mass or an object of mass 2 kg and it is thrown horizontally. So let us represent it with a vector of 45 meters per second. Just before it lands on the horizontal plane below, its velocity makes an angle. Okay, it might be a printing mistake. An angle of 20 degrees with the horizontal. So what does that mean? Let us say this is the plane below. Okay, so on a distant planet you can see that there is a mountain and there is a projectile being thrown on the plane below it, and it goes and falls on the plane, and while falling, just before it falls on that plane, it makes an angle of 20 degrees. Alright, so let us represent. Let me change the color for this. Okay, it makes an angle of 20 degrees. And the acceleration due to gravity on the planet is 15 meters per second. Alright, so the g value is given, that g is equal to 15. Now what do we need to do? We need to find the speed of the projectile just before landing. And if you observe this problem, it is basically like throwing a ball or a mass of 2 kg at an angle of 20 degrees up with some initial velocity v, because in physics and mainly in this problem the time is symmetric here. Even if you go forward in time or backward in time, everything remains symmetric. So what we can do is consider this problem in reverse. Let us say that I threw this ball or mass with initial velocity v. So when it reaches its maximum height, what will its velocity be in vy direction? So let me represent it like this. And since time is reverse, we have to consider everything in reverse. Okay, so vy is equal to v sine theta. The magnitudes will be same, only directions will be reversed. You can think of it like watching a movie of a ball being thrown in reverse, and Vx will be equal to V cos theta, and at the top its position, its direction of velocity would be like this, and so it should be equal to 45 meters per second. So V cos theta is equal to 45 meters per second, and we know theta is 20 degrees, so we can find the initial velocity, or here in this case the speed or the final velocity. So v is equal to 45 by cos 20, not radians, this is degrees, so we have to mention that it is degrees. Alright, so that answers the first question. Now find the time the projectile is in air. That means basically half the time of flight if we had thrown the ball in this direction and it completes a full parabola. Report your answer with two significant figures. Okay, we are not going to care about the significant figures now. We only care about the concept and the derivations of the formula. Okay, now what is time of flight? As I have explained before, time is equal to velocity in y direction. Here velocity in y direction will be v sine theta by acceleration. g. And in the previous video, I have explained that time of flight is 2u sine theta by g, right? But here we are considering only till the point where the object is at its maximum height. Or here, since we are throwing it from the maximum height till it reaches the ground, both will be symmetrical. So time is equal to v sine theta by g, and v is this much, 45 by cos 20. So multiplied by sine 20, we get 45 sine 20 by cos 20, which is 45 tan 20. So time will be v is 45 and tan 20. Remember to keep your calculators in degrees. 45 tan 20 by g. G is 15. And here everything is in SI, so we need not convert any units. So this will be the answer for time. Now, find the height from which the projectile was launched. Report your answer with 2 significant digits. Okay. How can we do this? We need to find the height. Okay. Now think, what formula relates the height? We have time, gravity, and velocity. We need to find height. What can we do? It's basically like in a free fall, what happens? The horizontal thing the gravity does not care about the horizontal velocity. We only care about the vertical, and initially there is no vertical velocity. So the time taken for the ball to go here will be equal to the time taken if the ball has just been dropped like this. Okay, so what can we do? Distance or height s is equal to ut, and what is initial velocity? 0, because we are considering in y direction only. U t, that is u is 0, and t we can substitute t this much, but it does not matter. Let's not care about it. Okay, u t plus half, and what is a? A is minus g, which is minus 15 t square. So you can calculate this and plug in the t value here, and this is just 0. So here we get the height is equal to minus 15 by 2 t square. Interesting thing here is, why is the height negative? Because we are starting from the maximum position. Height negative implies that it is not going above, but the height is below. That means it is actually, if you are considering this as the origin, the plane field below is minus 15 by 2 t square meters below the original point. So if you are considering from the plane, the height will be plus 15 by 2 t square. So that answers the height in meters, and since it is SI, we are not converting anything, so we get the height in meters. Find the horizontal range of the flight. Report your answer with 3. Okay. Now, you know the initial velocity 45 and you know the time. We need to know how far does it go. And why is this time relevant to this? Because the time taken for the body to fall from this height to the ground is exactly the time taken by the body to travel from this position to this position. So time will be equal. So what can we do? We know the initial velocity, and there is no acceleration in right side or x-axis direction. So we can use, let me change color. Okay, we can use v is equal to, what's the formula? V is equal to u plus at. And but does this give us the answer for the range? No. So what should we use? S is equal to ut plus half at square, but since we know that a is 0 in x-axis, we just keep it as 0. So what is u? U is the initial velocity, that is 45 meters per second, or x-axis velocity, that is 45 meters per second. So 45 into time, 45 square tan 20 degree by 15. So this is the range R. Hope you understood the concept well. Similarly, you can try many different problems. Like in this same example, if the body was not thrown to the right, but instead it was thrown with an angle. So how can you do that? You can do that by considering this as a level field, and for the body to reach this direction you can consider it as a one full parabola problem, and then from here you have to split it as the body being thrown like this, or you can consider the maximum, you can split it into two problems. This way would be better. You can take it till the body reaches its maximum height. So till then you can consider it as one problem, and then from the maximum height you can consider it as being thrown horizontally. So that problem will be similar to this one as I have just shown. So splitting the problems in this way by using the concept is a main crux of physics. Anyone can do mathematics, but analyzing the problem is the main thing in physics. So keep that in mind and think how the problem should be divided when what is being asked. Thank you.